Hello.
Yes, sir.
Okay, so is my screen visible to all of you?
No, sir.
No, sir.
Yes or no?
No, no, no.
No. So today we will see a program on generation of a random number where we are using the concept of a for loop, using the concept of array, and if some distribution is given, how to use the inverse transformation method to generate a random numbers using a specific distribution. So I hope my screen is now visible to all of you.
Yes, sir.
Yes, sir.
So write a program to generate random number from given distribution. Okay, so given distribution, let us say x is given uniform or x is distributed uniform with parameters a and b. Okay, so we know that what is the density function of uniform distribution. It is a 1 upon b minus a, where x is lies between a and b. Okay, so what is the form of where a and b greater than 0? So what is the fx? Fx is nothing but fx is nothing but it is the integration over 0 to x ft dt. What is that? It is 0 to x 1 upon b minus a dt. So we just take the 1 upon b minus a outside and integration of 0 to x 1 dx or 1 dt. So what is the integration of 1 with respect to x? Sorry,
X.
it is a
T. T. T.
t. So it is nothing but it is nothing but 1 upon b minus a t 0 to x. So it is nothing but, sorry, it is not 0 to, it is from a to x. No? You have to go to the previous slide. This is from a2, because lower limit is a and it is a distribution over, right? So it is a2. Wait, I have to just remove this. It is nothing but 1 upon b minus a in bracket x a2, sorry, it is a t a2 x. So it is nothing but x minus a upon b minus a. Okay, so we know that uniform this fx is nothing but it is a distribution function. And what is the range of distribution function? What is the range of distribution function? Yes,
0 to 1.
0 to 1. So we know that fx is lies, lies between 0 to 1. Okay, so what is the range of standard uniform? Range of standard uniform is 0 to
0 to 1.
1. So can we compare u equal to fx? Because when the range are same, we can easily compare. So which implies x equal to f inverse u. Okay, so this is called the inversion transformation. So what is fx in our case? What is fx in our case? It is this x minus a upon b minus a. So can we write u equal to x minus a upon b minus a, which implies x minus a equal to b minus a into u. Okay, so which implies we can write x equal to a plus b minus a into u. Okay, so what we do, we first generate the uniform random numbers, and then we just make this formula a plus b minus a into u. We will get the random number generation from a uniform distribution with range a and b. Is that fine? So what is the first step? What is the first step? First step is include necessary
Header file.
header files. What is the second step? You
Void.
have to, yes, you have to start with the void main, that is the beginning of a main function. Third step is you can use the
Open bracket. CLRSC.
clear command. Then you can declare the variables. So we know that uniform random number is lies between 0 to 1. Okay, and because I wish to find out the uniform random numbers like u1, u2 up to un, so I have to store them in a array. So how will you write in the array? It is a u1, u2, Likewise, un. Suppose if I wish to find out the n random numbers. So I have to declare the u into the plot. Plot u, and let us say I wish to generate the 100 uniform random numbers. Then a and b may be integer, a may be float. So let us declare that a is the lower limit and b is the upper limit, which is in the plot. And because I wish to store my output into the variable x, so I can also declare x as a array. Because I wish to apply the for loop, I require how many variables? So n observations. So n is integer. I require the I as a index. Okay. So this is what I wish to do. Now, what is my next task? Step 4 is, what is the step 4? After declaration, we will give information to
users.
users. What are the information? Please enter the number of observations. So how will you give that instruction? Using the command cout. Please enter the value of n. Then what is the next task? User will supply the value of n. So that is input of n by using the command cin. Then generate uniform random numbers. So which command is required? It requires the rand command. And rand work if you first introduce the randomize command. And this randomize command require the library stdlib.h. So you have to load the library stdlib.h. So you use the for loop for I running from 1 to n, okay, and you use the randomized number ui equal to, there is a function rand, and rand number is generating a numbers from 0 to maximum. So that is nothing but which command? It is a rand max. Okay. So after generating this, what is the next task? What is the next task? It is a, we have to calculate x of I using this formula, a plus b minus a into u of I, and then you have to print, then see out x this. Okay, then get ch and end of the bracket. Then you can use the Alter F9 to run and Control F9 for the running this. So Alter F9 for the control and Control F9 for the run. So let us go with you into the directly C++. So to open a new file, just go for the Alter F and for the new. Now what is the first step? As I say that we have to include the library. So type the hash include. That is nothing but preprocessor which can help you to include the library. Which library we are going to use? iostream.h. Second library is nothing but ponyo.h. Why the iostream? Iostream is nothing but it is a library associate with cin and cout command. And we know that to write a command we have to use the double slash. So this is a program for we'll write a program to generate 20 random numbers from uniform distribution with parameters a and b. Okay, so when you use the double slash, it becomes the comment. Compiler will understand it is a comment. Now, third library which we require, it is nothing but the because we are going to use the function random rand function, and rand function is available in the library standard library. Which library? It is a std lib. So include std lib dot h. That means standard library dot header file. This library is mainly useful for randomize generator. Okay, if you wish to find out the random number, then it will generate a random number from 0 to some maximum number, and then you divide the random numbers by that maximum value. It is converting from 0 to 1, and that is what we are looking, that random number should be generated from standard uniform 0 1. Okay, so now we start the main function and begin the program by the lab braces. As I told you that before going to write anything, we always use the clr command for the clearing the screen. Now to start the generator, we have to use the randomize function. Randomize function is also the part of the std lib. So when you give the randomize, what happens? Compiler will understand that now you have to start the random generators. Okay. So I told you that we will have to declare the variables. So n is integer, so I declare n as integers. Then I am using the for loop, so I am using the index, so I am declaring I as the integer variables. Right now I am require only 2. If requires, later on we can add. Then float, so a and b is nothing but the, let us say, some floating point numbers. We don't know whether the a is a integer or float. If nothing is given, then declare them as a float. And I am wish to generate a random numbers and which I wish to find out from uniform, and I am storing them as a array with the variable name u. So let us say I wish to store 100 elements. So how to declare the array? While declaring the array, you have to declare the type of array. So type of array is here float. array name is a U, and how many number of elements you would like to store? It is 100. So that should be given in a parenthesis, or sorry, square bracket. Then, because I wish to generate a random number from the distribution, uniform distribution with A and B parameters. So that output I wish to store into the array X. Okay. Whenever we require other things, we will go later on. So declaration is done. What is your next task? Your next task is you wish to provide the information to users. So you have to use the cout command, enter the value of n. N is nothing but number of random numbers which you wish to generate, the size of. ब्रैकेट में लिख सकते हैं size of random numbers. Anything you write into the double quote, it will printed on a monitor screen. Then for a next line, you can use the ender. Then user will get this information, and user wish to enter the value. How the computer will allow to enter into this program? By using the cin command. Okay, what is next task? I forgot. What is the next task? Anybody there?
Generate uniform random number.
Yes.
Generate uniform random number.
Generate uniform random numbers, but we wish to generate from the uniform with AB. So first we have to ask the users, please enter the lower limit of and upper limit of distribution function. So here we will again give the another message, enter the lower limit and upper limit of distribution. So what is the lower limit? It is a. So we will use the command C in A and B. So that means you can write, enter two different values. But of course, A is a lower limit. First you have to enter lower limit, and then you have to enter the upper limit. Okay. What is next task? After entering the lower limit, upper limit, we wish to generate the random numbers. So how many random numbers we wish to generate? N. So first, second, third, likewise, it should be n. So I have to use the for loop. For I equal to 1, I less than equal to n, semicolon I plus plus. And because I wish to generate a random numbers, and then I wish to calculate the xi. So I am giving the in the same loop ui equal to, so rand is a function, okay, which can take the integer value from 0 to rand max. Rand max means it is a seed limit is defined. Some large value is defined into the C++. So your random RAND command, what it will do? It will generate a random number from 0 to rand max. Now, if you divide each number by rand max, what happens? It is converting into the 0 to 1. But here I told you that rand is an integer. Rand max is also integer. So what is the answer of integer by integer division?
Integer.
It is integer. So always you will get the 0, because 0 to 1 and any fractional value between the 0 to 1, it is taking the lower integer value, so you always get the 0 answer. So that is how I have to make any one of them as a float. How to make the float? Just multiply the rand by one dot. Okay, so what happened now? I have make this is a rand function giving the random numbers between 0 to rand max. I am multiplying one dot, it means I am making this as a float. Float by integer answer is
Float.
float. Now uniform random numbers are generated and it is stored into the variable u. When I takes value 1, it is a u1 first random numbers. I takes value 2, it is a second. So how many such numbers are generated when I less than or equal to n? So when I reach n, it will generate the nth random numbers from uniform standard uniform. Now, but my aim is that I wish to generate a random numbers from uniform with AB. So what happen? I will do this transformation a plus b minus a into u of I. So this is my generation process is done. I have generated the random numbers from uniform AB. Now I wish to print output. So cout generated random numbers from uniform AB are. So I wish to display the first output. I wish to display the output like that. What output I wish to display? First, I wish to show that the uniform numbers, and side I will show you the generated uniform numbers from random numbers from uniform AB. So I will use this command cout. What I wish to print u, then bracket. Then the index value will be changed. So I will give again double shift, left shift, then double quote. This is the bracket over double quote. That means what happen every time it will print u bracket and I will be changing bracket over, but it is in the for loop. So I have to write in a for loop. Then what is the output? The output is UI because it is stored into the UI. Then what happen? I wish to give the space between the uniform random numbers UI and XI. So the 8 character space is given by the single quote slash T. It means it is a tab. Tab key is a slash T means it is a horizontal tab. Then I wish to display X bracket. Again I is changing. Then bracket equal to this XI. And then what happen? What it will do? When I takes value 1, it will print u1 equal to whatever the uniform random number generated, it will store in the u1, and then there is 8 character space, and then it will print x1 equal to whatever the value of x1. Similarly, I takes value 2, it is output is u2 equal to uniform numbers whatever generated at the second position, and x2 is nothing but the whatever the value you have obtained in the second numbers of x2. So that's all. Then you have to give the get ch and then save. So to save you have to press the F2. Random number generation from unique. Okay. So I have to just save this. Is that clear? So what first we have done? In the first case, we have calculated the x in terms of a standard uniform, and we obtain x equal to b minus a plus b minus a into u. So to write this program, I have to add the necessary header files. I have added the necessary header files like iostream conio.h. Why? Because I wish to use the input output. So I have to use the iostream header file. If I wish to go for the using of the clrscr and the getch, then I have to use the conio.h header file. And because I wish to use the rend function, which is the part of the std so I have to load the standard library.h, std And now you have to start the main function. So void main, anything you wish to write, it should be written in the main function. Then the beginning of the program is by the left braces, curly braces, because I wish to first clear the output screen. So I have to use the command clrscr, and I wish to start random number generator. So I have to use the command randomize, and which is the part of stdlib. And because I wish to use the for loop, and I wish to generate the, let us say, n random numbers. N is 20, so we will ask the users, okay, supply the information of n. I am just declaring the n as an integer, and I is nothing but it is the index for the for loop. I wish to generate a random numbers from a uniform numbers with a and b. A is the lower limit and b is the upper limit. So I have to supply a and b as a float because I don't know whether it is integer or float. It can be anything because you have to write the program, general program for the users. Okay. Then you have to enter the after a and b, because you wish to generate a uniform random numbers. So uniform random numbers is always lies between 0 to 1. So it is a float. So I have to declare in the float. But uniform random numbers I wish to store in an array. So how many maximum element I wish to store? 100. So u is the array name, and if I have the one square of bracket associated with u, it is indication that I am introducing one dimensional array. So how many maximum element I would like to store? 100. So I have given here 100. Similarly, x is nothing but it is a transform variable of a standard uniform. So it is also array. So I have declared them as a x as array. One parenthesis is square bracket is a pair of square bracket indicating it is a one dimensional array, and 100 elements I wish to store. Anything is terminated by the any whatever the statement you have written in C++, it is terminated by the semicolon. Okay, so that is how I have given. Now I wish to supply the users the information, enter the value of n. So I have to use the cout command. How whenever a user wish to enter this value, how the C++ will allow them to by using the cin command. Then I have asked the users to supply the information of lower limit and upper limit of the distribution. So there are two, A and B. So I have given the C in A and B. Now, what is my aim? My aim is that I wish to generate a random numbers. But here you can generate a random numbers which are in integer, which can be lies between 0 to rand max. Rand max is a some upper limit or the seed is given. So because I wish to generate a random number from 0 to 1, I have divided the rand by the rand max. So it is lies between 0 to 1. But rand is an integer, rand max is an integer, so integer by integer is answer is 0. So it is integer. So it always become the 0. So I have just make the any one of them as a float, either denominators or numerators. How to make the float? Just multiply with the one dot. So I'm because I wish to generate a n random numbers, so I'm using for loop, and ui stands for the it is the ith uniform random number generation, and xi means it is a plus b minus a into ui. So my generation part is over. Then I wish to display the output, but I wish to display the output u1 equal to some numbers and then nearby x1 equal to some numbers. So here I wish to every time print u bracket and this bracket equal to, but the between index should be changed. So I have write in this format. So every time index is changing and I'm using for loop, this is the my UI is nothing but the output is stored into the ith array, and then there is a horizontal tab. That means that I wish to allow the space between the two variable using the horizontal tab. So there is a command /t. You can see that I have just enclosed in a single quote. So it is indicating that it is a character constant. I told you there are three types of constant. String constant. Anything is written in double quote, it is called string constant. Then numeric constant. Numeric constant may be integer and floating point constant. And third one is a character constant. Anything is written in the enclosed in the single quote, it is said to be a character constant. So then xi I have printed, and then the output where the xi is stored, that I have recalled, and then the my end of the program. Okay, so let us run Alter F9. As I told you that whenever you are using the for loop, if only single statement is associated with for loop, there is no need of a curly braces. If you wish to write the several statements which should be executed after for loop, then you require the curly braces. You can see that in the above for loop I wish to execute two statements together. That is I have given in a curly braces. But here I wish to execute only one statement. This. So there is no need of a curly braces. So as such there is no error. Just perform the control F9 to run. Now it is giving the message on a screen. Enter the value of n. So I wish to generate how many random numbers? 20. Then again it is asking that please enter the value of lower limit and upper limit of the distribution. So I know that I wish to generate a random numbers from, let us say, 2, and lower limit is 2 and upper limit is 4. So A is 2 and B is 4. Then it has given the 20 random numbers. I told you that I wish to print the output u1 equal to whatever numbers, u2 equal to, u3 equal to, and after 8 character space, I wish to display x1, x2. So you can see that the all UIs are lies between 0 to 1. None of the value is greater than 1. Okay, if you get some value greater than 0 in UI, then there is a suspect that something is wrong. And you can see that all the xis is lies between 2 to 4. None of them is greater than 4, none of them is less than 2. So it is saying that the required random numbers are generated. And everyone has the different output. Why? Why everyone has the different output? Yes, anyone?
Because it is a random numbers.
It is a random numbers. Very good. Okay. So this is where you can calculate the random numbers from a standard, uniform random numbers between A to B. But every time you have to generate the uniform random numbers. Why? Because you wish to use the formula. This one. Because you wish to always use this formula, fx equal to u, which implies x equal to f inverse u. So every time you have to generate these random numbers from 0 to 1, and whatever the transformation you are applying, you will get. So now, second program. I wish to generate a random number from exponential distribution. Let us say x follows exponential, okay, where fx equal to lambda into e raised to minus lambda x. So we know that what is fx? You can verify at home. It is a 1 minus e raised to minus lambda x. It is said to be a cumulative distribution function. Above is a density function. So what will you do? What is the u equal to fx? That is 1 minus e raised to minus lambda x, which implies x equal to 1 minus, sorry, which implies e raised to minus lambda x equal to 1 minus u, so which implies minus lambda x equal to log of 1 minus u, which implies x equal to minus 1 upon lambda into log 1 minus u. So first you have to generate the random numbers this, apply this transformation, the data is generated from the required exponential. Okay, so we write a program. So let us, I will close this and then I will again open the new one. File, new. So generate random numbers of size n from exponential distribution with scale parameter lambda. So now I will quickly writing, include the necessary header files, stream.h, include onio.h, include stdlib.h for a randomize and print function, void main, that is the beginning of the program, clear scr to clear the screen, randomize command I have to use to start the random generators. How many? So n numbers, I is a index value, in float it is a lambda, it is some fractional value because it is a scale parameter, I don't know. So let me declare them as this, and I wish to generate the uniform random numbers. I can declare them as a u as a array, and x is nothing but the array where the data is from exponential distribution. Then I wish to give the information to users. Please enter the value of n User will supply the value by using the scene command. Then I'm asking users, please supply the value of lambda. Give value of lambda, because I have declared the lambda in a small letter. I have to give that as a scene. Then I will generate the random numbers from uniform using the for loop, because I wish to generate every time. I will store into the UI variable. Command is a rand function, and I wish to make them as a float. One dot or one dot by zero, it doesn't make much sense. Then you can maximum size is rand max. Uniform numbers are generated and stored into the variable UI. Now what is xi? So we know that xi equal to, what is the form? Anybody remember? It is a minus 1 by lambda into log. By default it is taking a log base e. If you wish to give the log base 10, then you have to use the different log command, but you have to supply the base value. 1 minus uniform random numbers UI. Okay, so this bracket of log is over here, and there is no need of this bracket. I have given additional. Yeah, otherwise it will give the errors. And because I have declared the lambda as a float, so 1 by float is integer is a float. So float into this result is a float. Now see out generated random number from exponential distribution. Okay. I wish to use the this particularly both output together, u and I, so that are stored in the array. So to recall them or to use it, I have to use the for loop. See out x bracket on the double quote is over. I should be changed every time. UI. Here not x, it is a u. First I will let this one there. And then slash t in a single quote. Then I will int x. Whatever you wish to print, that you have to write in a double quote. Ch so is a random numbers from txt. Okay. Now we will run it. To compile it, Alt F9. It is showing errors. One errors. Where the errors? Let us verify. Log should have a prototype. So what is the errors? Log should have a prototype means log should have a prototype. What do you mean by that?
Maybe library.
Yes, you require the library because log is a mathematical function. So I have not loaded the library. So whenever you get the prototype errors, it means the corresponding library is missing. So I have to use math library is a mat.h using the include command. And again I will run, was compiled, so now there is no errors. Then run using the control F9. I wish to generate the 10 random numbers with, let us say, parameters is 1.5 lambda. So this is giving the required random number. Okay. So you can have the 10 observation from uniform and the corresponding you can have a exponential. Suppose if you wish to generate the random numbers from scale parameter 2. So you can say that if you find out the, by looking at the observation, if you find out the mean, what is the answer? Mean is almost zero 0.5. So if the shape scale parameter is half, then the mean is nothing but the ratio of the scale parameter. Here I have used the curly braces instead of the square bracket. That is how it is showing in this output. If I give the 0.5 as a scale parameters, you can see that the value is nearby. Okay. So if you find out this average of x, sum of all observation divided by the n, it is giving the value nearby 2. So when the scale parameter is zero 0.5, so what is the mean of exponential? It is a 1 by lambda. So 1 by zero 0.5 is a 2. So more or less you can get the mean is near to 2. It is just to verify whether the our data are generated from the exponential or not. So any questions, anyone? Any questions?
No, sir.
No, sir.
Okay, so if no question, then I will stop and take your attendance.